Hello, welcome to the eMath learning platform once again. Now in this video, I'm going to make it as short as possible. I'm going to only show you how to differentiate secx from first principles. So you're going to be differentiating secx from first principles. So I will say derivative of secx from first principles. Derivative of secx from first principles. Now what we're going to do is to first realize that for secx we can't let y to be 1 out of cos x, because secx is the same as 1 over cos x. Then from this we shall take a small change on y as we take a corresponding small change on x. So we shall have x plus delta x there also. Then the next step is to make delta y the subject, and if delta y is made the subject, it becomes 1 divided by cos of x plus delta x minus 1 out of cos x minus 1 out of cos x. Now from this level we're going to basically look for the LCM, and the LCM is going to be the product of cos of x plus delta x and cos x. And if this is the LCM, it means on the numerator we shall have cos x minus cos of x plus delta x. Then from this level we can now look at the numerator and we realize it is the difference of two cosines. Now it takes us back to the factor formula. You have to recall that if you have cos A minus cos B, it is the same as minus 2 sine A plus B out of 2, then sine A minus B out of 2. So that is what I'm going to use for the numerator, so that I have delta y as minus 2 sine of x plus delta x divided by 2, then cosine again of x, but this time it will be minus x minus delta x minus delta x, but all this divided by 2. Then the next step, of course, before we go to the next step, we have to divide by cos of x plus delta x, then cos of x. Now if we continue and simplify this step here, we shall come up with delta y as minus 2. That will be x plus x is 2x, divide by 2 you get x. So I will have sine of x plus delta x out of 2. Then this will be sine, I have x cancelling with x, so I made with negative delta x, but divided by 2. All this again divided by cos of x plus delta x multiplied by cos of x. From this level we shall now make the assumption that for small angles in radians, sine of delta x out of 2 is approximately delta x out of 2. But remember, a sine of a negative angle is as good as a negative sine of that positive angle. So we shall first have a 2 positive. Why? Because the negative we had on sine, on the angle of sine in this case, has come out to multiply itself by the negative we had here. So now from this level we shall now bring the assumption that for small angles, delta x, sine delta x out of 2 is approximately delta x out of 2. That now means that delta y becomes 2, the 2 we have here. Now this is all approximating to delta x out of 2, but we are remaining with sine of x plus delta x out of 2. All this divided by cos of x plus delta x, then cos of x. From this level, we can now realize that the 2 and the 2 can cancel. So we remain with delta x on the right hand side, multiplying sine of x plus delta x out of 2. All this divided by cos of x plus delta x, then cos of x. And if you divide now both sides by delta x, I will multiply this side by 1 out of delta x, because dividing by delta x means multiplying by the reciprocal. So delta x and delta x can now cancel, so that will remain with delta y out of delta x is equals to sine of x plus delta x divided by 2. All this divided by cos of x plus delta x, then cos of x. So from this level, we shall now make an assumption that in limits as delta x tends to 0, comma, delta y out of delta x out of delta x tends to dy dx. What does that mean? It now means that the dy dx, because this is now dy dx, is going to be the same as sine of x plus, it would be 0 now, because as you can see this, we have sine x, then this is 0 out of 2, which is 0. So I'll remain with sine x alone in the numerator, divided by cos of x, but cos of x again, because now this is also 0. This is 0, so we have cos x times cos x. Now what I'm going to do is, I'm going to consider this this sine out of cos together to give me tan x. Then remember there is a silent 1 over cos. The silent 1 over cos is the same as sec. So it means the answer comes to sec x tan x. The answer comes to sec x tan x. So from today, when you differentiate sec x, expect yourself to end up with your result as sec x tan x. This will be the end of this video, so that we keep a good quality of it. So we shall now go to the next video where we shall differentiate cosec from first principles.